그럼 이제 마일스베리 교수님을 단상으로 모시겠습니다. 큰 박수로 환영해 주시기 바랍니다.
Thank you very much. Can I say firstly what a great pleasure it is to be here today. I'm greatly enjoying my visit to Seoul. It is lovely to be in your wonderful, wonderful country. So yes, I'm going to do 5 things in the next 20 minutes or so. Give you some idea of how the UK sees textbooks, talk about some of the resources which we've produced as part of computing at schools, walk you through what we've done for switched-on computing, which is a scheme of work for elementary education, then look at a textbook scheme which we've done for middle school education called Compute It, and then talk a little about the broader ecosystem around computing education in England. Neil's already talked to you a little about our computing curriculum. We have 3 domains to the computing curriculum. There are elements of computer science, of information technology and digital literacy all intertwined in our computing curriculum. It is wrong to think of it purely in terms of computer science, or worse still, just in terms of coding. The best way to think of this is in terms of the foundations of the discipline, the ideas, the principles that underpin it, the applications of computing in order to be able to get useful things done with a range of application software, and then the implications of this for me as an individual, for us as a society. And a broad and balanced approach to computing education needs to encompass, I would argue, those 3 domains. As Neil's already indicated, the computing curriculum is incredibly brief in England. It fits on 2 sides of A4. You don't need to copy all of this down. What we have there is little more than the building regulations. It's the minimum entitlement. It is a statutorily prescribed thing. Local authority maintained schools have to teach the national curriculum, but the way they do that and what else they do as well, and what resources, what schemes of work they choose to support that work is entirely up to them. So we have the building regulations, but each school is responsible for its own plan of doing that. The architect's plans have to comply with the building regs, but the architect's plans are down to each school in terms of their local context, their vision for learning, for teaching, for education, the resources that they have at their disposal. The textbook can bridge the gap from one to the other. So our Minister of State for School Improvement sees the textbook as providing the fleshing out of the content of the programme of study. The programme of study is very minimal, but a good textbook bridges the gap and shows what that means in practice and provides a structure that schools can use to deliver a rich education base which complies with the programme of study but goes far beyond the minimum requirements there. You have, if you will, for those of you with a background in software engineering, something akin to a waterfall development process. Government publishes a list of requirements of this is what should happen. There's then the process of designing schemes of work, of textbook schemes or resources or whatever, which implement something which meets those requirements. The job of then doing that in practice is down to teachers in classrooms who have had very little say in either of the first 2 steps on this model. There's of course the need to test whether that works, to verify whether that's been effective, and if it's not, then there'll be the maintenance pack, the upgrade at some point, I'm sure, which brings things back closer to the original requirements, or maybe the original requirements change. So our Minister of State can make statements like counting as a success when teachers are able to laminate their lesson plans and use them from year to year. I share this, though, with my colleagues teaching in primary and secondary schools in England, and they laugh when I show this slide. The primary teachers laugh because they say, I have a different class every year. The children in front of me are different. How can I just teach the same lesson every year? Secondary colleagues laugh at this slide because the curriculum changes, or rather the exam specifications change so frequently that they need to move with that rather than the curriculum requirement. I would take issue with this because it's only my perfect lessons that I want to laminate. When I've taught a perfect lesson, then I should laminate the plans. But until then, I should be aiming to improve that continuously from one year to the next. So I'm not sure that the laminated lesson plans entirely solve the problem there. Alongside waterfall development, we have the other model of agile development. And I think for teachers in England, This is much, much closer to their vision for what education should be like. So yes, the things on the left of this slide matter, but actually the reasons they become teachers is much closer to the statements on the right-hand side about being responsive to change, about focusing on the individuals and the interactions with the children who are with them in the room, rather than necessarily following a comprehensively documented, rigorous process there. And there is that tension in English schools, and so textbooks have not been popular in English primary schools. I think going back to the 1960s with a very influential report for English education, the heart of the educational process lies the child. And teachers in English primary schools still are good. However many this is like almost 50 years on from the Plowden report, see their job as about developing children's love of learning rather than necessarily passing on a particularly restricted or circumscribed body of knowledge. Nevertheless, there is a lot of interest in England about doing textbooks well, and so one of our leading education academics, Tim Oates, has looked at globally the best textbooks and makes a number of observations about what a really good textbook should be like. And, you know, from the slide there, underpinned by well-grounded learning theory and theory regarding the subject-specific content. Nobody in the room would disagree with that. English teachers would not disagree with that. It should be embedded in the best possible practice. Our Education Inspectorate, who are hugely influential in English education, also make recommendations about what a good curriculum looks like. Just picking out from that, the curriculum should be broad and balanced, with all three strands of computing covered well for all pupils in computing lessons and across the curriculum. The contexts in which computing are taught should be relevant to people's lives and reflect the increasing use of computing in the world of industry. Links should be forged with other agencies and the wider community to provide a wide range of enrichment activities to promote pupils' learning and engagement with the subject. Very, very similar to the vision which you've already heard for textbooks to support software education in Korea. And further points from our friends at our Education Inspectorate. Pupils are expected to use their computing knowledge, skills and understanding realistic and challenging situations. So that's not a requirement, but it's certainly an expectation of what outstanding computing education should be like. I want to move on to look at the resources which we at Computing at Schools have developed together as an organisation. Many of our members have produced their own teaching resources. What we've done together as an organisation is produce resources for teachers. We see the real issue in terms of teachers' own subject knowledge of computer science. And so one of the first things which we did was produce the guide to the new curriculum. The curriculum, as you see, fits on 2 pages of A4. We've produced slightly more extensive guidance notes to that about what the words mean and what that's going to look like in practice for both primary and secondary education. I think our model comes down to this, that outstanding education in computing rests on great pedagogy, great teaching, also a good set of technical skills. Being able to make the machines work seems to matter, as well as computer science subject knowledge. We take the first two almost for granted, but the third one there, the computer science subject knowledge, is new for our teachers. We're expecting our teachers to teach something they themselves were never taught. So we have the Barefoot Computing program aimed particularly at primary schools, which addresses exactly that computer science subject knowledge through a set of subject-based workshops where teachers come together to learn about computer science, where there are teach-yourself resources online for them to print off and read, and activities that they can put that into practice with their own pupils in class. And we have this approach to computational thinking, which, yes, recognizing those fundamental concepts such as logic, such as algorithms, such as course as abstraction, but also a cluster of approaches that computer scientists and software engineers engage in, like tinkering with things, like making things, like fixing things when they go wrong, which is an important part of our curriculum, like persevering when things don't go well, and of course, as already been indicated, collaborating, working together. We've also produced the CPD pack, the shrink-wrapped pack for teachers wanting to run continuing professional development sessions for their colleagues, and that's badged as Quick Start Computing for primary and secondary. And this is all under a liberal Creative Commons license. Download that. Feel free to translate this into Korean if you would like to. I want to move on now to Switched On Computing, which is my commercial scheme of work for the primary age, I should say our award-winning primary scheme of work for computing. And for this, we started from this English phrase about not throwing out the baby with the bathwater. Does that translate into Korean? I wonder. That there was nothing on the old ICT curriculum that we rejected. All of the old information technology is still there, but we added on some new. So we started with something that was working well and have now tried to make it work better. When we scoped out Switched On Computing, we took the curriculum and saw 6 strands running through it. Programming, computational thinking, networks and the internet, very important ideas, together with perhaps softer IT areas such as communicating and collaborating, creativity and productivity. These are not disjoint areas, but they are 6 areas of focus. So that divides nicely into the computer science bit and the information technology bit, embedding the digital literacy implications across all of that. We had a very successful product already, Switched On ICT, and we edited that, we revised that to make Switched On Computing. So the pink strands on there is where we had units in Switched On ICT, which we revised to reflect the new expectations, and the blue units are where it's new work written entirely. You'll have to forgive the expression from scratch to start that. Down the bottom here, year 6, a complete new unit of work focused on developing apps across the whole of the year. So planning the app, finding whether there would be a market for it, designing user interface, then doing the coding, and then testing and marketing that. And this has proved very, very successful. For this, we've used wherever possible free resources, commercial scheme of work, as I say, so we're drawing on software which is available freely to use across schools. So of course we're using Scratch for programming, but we're also moving on to App Inventor or App Maker in those year 6 units, or Touch Develop, and similar things for the information technology side of this. I'd say, or we would say, that we were allowing about an hour a week for each of 6 years for this scheme of work. And that's quite different from a 17-hour computer science curriculum in primary education. What does it look like? It's a teacher's guide. It's not a textbook. We're very much in the model of this is a plan for teachers to use, and they then teach their pupils to do this. They set meaningful, challenging activities for pupils rather than give them a book to follow there, which may or may not work in other contexts. So we introduce the topic, we put it in the context of the computing program study, we provide a little bit of information about what that means, we warn them about some of the safety issues which might be associated with using particular tools, and give them links to places they can go to read more. We then break each unit down into 6 steps, and then detailed bullet point by bullet point. It's an algorithm for teaching this particular objective, I suppose. And then ideas for extension activity at school and home. We also bring in assessment there with fairly detailed criteria of what to look for in terms of what a child should be able to do. So a child following that unit of work should be able to break the scene down into smaller sections, write a program in Scratch to create an animation, but the most able in the class might also be able to think logically to detect and correct errors in their algorithm or their program, and perhaps publish their animations out to the Scratch community website. And they then link to digital badges, so a child provides evidence of being able to do all of the particular things for one badge, and then can have that badge to wear on their blazer or on their blog, depending. So here we have the sort of criteria for one of the programming badges at younger elementary and then older elementary level. On the back of that, our colleague Claire Lautrier has produced for the same publisher a Learn to Code sequence of books, which is much, much closer to a textbook-like approach of follow these steps. Here is a plan for your program, and then you'll get to see this in action. There are copies of that outside if you'd like to have a look at it later, or at least to Switched On Computing. Moving on to Compute It, which is a scheme of work that, textbook scheme that Hodder have produced for lower secondary education. The approach there has been a somewhat different one in that firstly it's a traditional textbook-like approach, and secondly they've focused particularly on the computer science elements of the curriculum. So they've taken the assumption that information and technology and digital literacy was being done well in secondary schools, but computer science, the new bit of the curriculum, was where the greatest need was for a textbook. And they divide the curriculum for computer science into those 6 strands and have very detailed progression planning through each of these 6 strands. I'll just give you a moment to note all of that information down. Okay. They then take the contents of compute, it then forms the outline of a scheme of work there. So I'm sorry the text is so small and only in English on the slide there, but in Unit 1 in year 7, so our 11-year-olds in secondary school, what's under the hood of a computer? Thinking like a computer scientist, which is obviously bringing in computational thinking territory, and then drawing and manipulating shapes. Taking that as an example, this is what the textbook looks like. So here is the pupil-facing text. This is the sort of information which the young person, the 11-year-old, would be given. And there's a challenge activity there at the start. So yes, it's a textbook, but it's a project-based approach to teaching computing. Your challenge is to write a program that creates an artwork based on drawing and positioning shapes found in Celtic or Islamic art. And so it starts very simply with the turtle, the logo language to draw a square, and then moves beyond that relatively rapidly. Alongside that, of course, there's the teacher's guide. There's also very good online support materials. So there's this dynamic learning website where PDF versions and interactive activities are all available, together with the notes that the teacher needs in order to contextualize what the pupils are working on from the textbook there. Okay, I want to move on though to think about the broader ecosystem that sits around these textbook schemes. I should firstly say other textbooks are available. I've just picked a couple of examples there. We don't have any sort of government approval for textbooks there, although both of these are probably the dominant products in their respective marketplaces. So looking at the broader ecosystem, this isn't about education. This is the government digital service in the UK. The people who make our government's website have as one of their design principles this fairly political statement: government should only do what only government can do, which is a very small government approach to things. That if the sector, the broader public sector, voluntary organisations, commercial organisations can do something, then government doesn't need to do that. And so letting the market decide what's a good textbook, letting the market and the voluntary organisations produce materials, our government has decided to step out of that, to create a very minimal statutory curriculum, and then let the people decide how to implement that. And that perhaps is quite different to other approaches. A former Secretary of State for Education, the man probably responsible for having computing there as a national curriculum subject, Michael Gove, when he talked about the changes, mentioned this sort of wiki approach to a curriculum. That beyond the slimmed down national curriculum, he said we should consider how we could take a wiki collaborative approach to developing new curriculum materials, using tech platforms to their full advantage and creating something far more sophisticated than anything previously available. I'm not sure whether we've realized that vision, but it certainly informs some of what we've done. For any of you involved in open source software, you have the classic essay from Eric Raymond about the cathedral and the bazaar. And Raymond contrasts the sort of cathedral-like edifice of commercial top-down waterfall-like software with the much more bizarre, or possibly bizarre, approach of open source communities gathering together to make something, drawing on a range of talents. And so I think traditional textbook schemes have perhaps come under that cathedral-like territory, whereas what we're seeing in the wider ecosystem is much closer to a marketplace where we all bring something special of our own and share it openly, not necessarily freely, but very often freely. So within computing at schools, our members freely of their own choice submit resources that they've produced. That can just be a set of PowerPoint slides for one lesson or another. It can be a Scratch program that they've written and found particularly useful, or it can be a fully developed scheme of work that they could have sold for real live money, but they've chosen to share that freely within the Computing at Schools community. 3,781 resources on there when I put the slide together, with the default setting that these are shared under a Creative Commons attribution share-alike license. So as long as you acknowledge where it came from and are happy for other people to use your work, you can take it and edit it. The CAS resource site is a wiki. There's an edit button on every page in there. Not that that always gets used. We have other people too. So we have a not-for-profit organisation called Code Club. There's running after-school coding clubs for 9 to 11-year-olds. And again, their resources are freely available there on the web, and a great set of lesson plans, activity plans for Scratch, but moving beyond Scratch into HTML and CSS and Python and other things on there too. And we know of a number of schools that are not using that as an after-school activity. They're using this as the basis for their lessons. In terms of hardware, the Raspberry Pi has captured the interest of, well, basically blokes of my generation in England, but also some younger people too. So it's an appealing physical hardware computing platform to develop where you get access to the network layer, where you get access to the input-output pins, where the default operating system is Linux rather than Windows or OS X. And that's interesting. And Raspberry Pi Foundation are very supportive of a number of educational projects and produce their own teaching resources. Our national broadcaster, the BBC, have got on board with this initiative too, declaring 2015 their Year of Code, with a range of programmes across a range of media, including broadcast television, but much more of it online. So lots and lots of high-quality resources aimed not so much at teachers, which is what Computing at School is focused on, but the pupils themselves, of practical activities and things where children themselves can learn about this. And this lovely little microbit, tiny computer with a 25-pixel display. How's that for state of the art? And an A button and a B button. But this notion of getting children making something using very simple platforms like that, and the idea that next October, one of these will be given to every 11-year-old throughout the UK, I see as a tremendously exciting thing, assuming it works out okay. I think that's all I wanted to talk about this afternoon. I do the Twittery thing if people want to follow up with questions there, but I'll stand on stage and answer some of these in person as well. Thank you ever so much.
네, 오늘 주제에 대해 발표해주신 마이클 교수님께 감사드립니다.
네, 안녕하세요. 먼저 연구자를 직접 오셔가지고 열정적으로 발표해 주신 것에 대해 굉장히 감사합니다. 제가 이제 질문하고 싶은 것은 이제 교과서를 제작을 하거나 교육과정을 구성하는 데 있어서 가장 중요한 것은 국가적인 교육 목표라고 생각을 하는데요. 2015년 2월에 발표한 운영지침과는 달리 8월에 교육부에서 발표한 자료에 따르면 컴퓨팅 사고력을 기르기 위한 인재 양성도 있지만 소프트웨어 산업을 위한 인재를 육성하고자 하는 방향도 들어있는 것 같아요. 그런데 이제 제 개인적인 생각에서는 컴퓨팅 사고력을 기르는 것은 정보과학적 소양이고 또 보통 교육으로서 추진을 해야 한다고 생각하고 직업에 대한 교육은 심화 교육으로 해야 한다는 생각을 하고 있는데 영국에서 교육에 대한 국가적인 목표는 무엇인지 궁금하고 또 한국 교수님들은 어떻게 생각을 하고 계시는지 궁금합니다.
네, 이 부분에 대해서 아마 두 분 교수님께 다 대답을 들어야 할 것 같은데요. 먼저 마일스베리 교수님 말씀하시고 김현철 교수님 답변 듣겠습니다.
That's a very good question, and the overall aim of UK education is not something which we often talk about in the UK. We do have a statutory requirement in terms of curriculum content, and that's that the curriculum for a school be broad and balanced, and it prepare young people for the opportunities, responsibilities and experiences of later life. And as Neil argued with taking the example of his son, what is the later life of a child who enters kindergarten, who enters elementary school this year going to be like? it seems to me that digital technology is likely to play a more important role in those children's later life than it has even in mine. So preparing children for a world that we really cannot even imagine is one of the things which is there as a statutory aim for our curriculum, whatever that may mean in practice. When we were designing or drafting the English computing curriculum, at the back of my mind was this quote from William Morris, a 19th century graphic artist in England, who said, "Don't put anything in your house unless you know that it's useful or believe that it's beautiful." And I think if you translate that into curriculum design, you include on your curriculum things which you know young people are going to find useful. So yes, being able to find things out on the internet, being able to make a presentation, they're useful skills. But you also teach things that they will find interesting, and an understanding of how software works, of the principles that underpin computation. Well, it's something I find interesting, and surely that means everybody ought to find it interesting. Yes. We have also, though, this notion of what do we include on the curriculum. I don't know enough about the Korean curriculum. I would love to learn more. But we teach children in England at primary school things like poetry and music and painting, not because we need more professional poets or musicians or artists, but because these are things that are an integral part of a rounded liberal education. And I would argue that computing, that programming is now on a list comparable to that. You can't really claim to be educated unless you can appreciate music and art and poetry. And I would say the same applies now to code, unless you've got some sense of what it is and why it works, how it works. And that ought to be part of everybody's rounded education. Returning closer to the question which you originally asked, very few of your pupils, none I suspect, will ever get jobs programming in Scratch. Some may get jobs programming in Python or C or whatever languages succeed those, and Scratch is the first step along a journey to developing competence in that. But we don't teach them all these things because it's important vocational training for the software industry. We teach the coding skills because it seems the best way to develop this computational thinking, this ability to look at problems, to understand systems, which draws on the insights that only computer science can bring, would be my argument.
네, 김현철 교수님께도 답변 듣겠습니다.
제가 말씀드리겠습니다. 아까 질문하신 분이 얘기하신 거는 지난주에 국무회의 그 자료, 교육부에서 그거 말씀하신 것 같아요. 그죠? 국무회의 자료는 굉장히 많은 정부 부처에서 이제 다른 관점으로 보기 때문에 그런 게 들어간 것 같아요. 근데 교육부나 미래창조과학부나 그 다음에 저희 학회나 연합회에서 단 한 번도 실수로라도 산업 관점에서 얘기한 적은 없어요. 교육 과정을 만질 때도 마찬가지입니다. 그거는 여러 가지 오해를 불러들일 수 있기 때문에 그렇지 않고, 지금 마일스 베리 선생님께서 얘기하신 것처럼 스크래치를 가르치는데 스크래치가 무슨 산업에 필요하겠어요? 스크래치 아는 거가요. 그리고 아두이노 배운다고 해서 어디에 취업을 하겠어요? 아두이노가. 그게 아니고 그걸 통해서 디지털 역량과 그 다음에 컴퓨팅 사고력을 키우는 거가 철저하게 그게 100%입니다. 100%예요. 근데 속으로는 그런 마음은 있어요. 예를 하나 들면은 저희 학과 경영학과 학생이 저희 그 교양 수업을 이렇게 컴퓨팅 사고로 교양 수업을 들었는데, 우리 학교 그 경영학과 학생들 취업이 안 되기 시작한대요. 올해서부터 이제 취업률에 문제가 되잖아요. 왜 그러냐면은 경영학과에서 배운 20년 전의 회계학, 20년 전의 마케팅 기법이 지금 회사에서 필요한 역량이라는 거예요. 컴퓨터 회사가 아니더라도 은행인데 은행에서 그 역량이 필요한 거죠. 그런 사람 많이 있잖아요. 그죠? 근데 이 학생이 그런 이유 때문에 수업을 듣고 여러 가지 지금 프로그램 수업을 듣고 있는데, 그 듣는 이유가 그 경영학과 학생이 프로그래머가 되기 위한 게 아니에요. IT 업체에 취업하기 위한 게 아니에요. 자기는 게임 회사를 운영하고 싶대요. 그 다음에 구글이나 이런 회사에, 그 다음에 은행에서 은행원으로 취업을 하고 싶대요. 근데 컴퓨팅을 배우고 프로그래밍을 함으로써 얻어진 역량이 도움이 된다는 거예요. 그 은행을 아니면은 게임 회사를 자기가 운영을 하는데 경영자로서. 그래서 배우는 거지. 그래서 지금 산업들은 모두 그러한 역량을 필요한 거지. 우리가 이걸 배워서 뭐 스크래치 개발자로 내가 떼돈을 벌 수 있는 건 아니니까. 그리고 우리 교육 과정도 철저하게 그거는 계속 유지를 해나가고 있습니다.
네, 답변 감사드립니다. 지금 시간이 좀